Okay, welcome to this next video. Today we're going to be talking about graphs and the special form y equals mx plus c. So you're still got the learning goal of understanding linear relations, and at the end of this you want to be able to calculate the gradient of a linear function and sketch a linear function using the gradient and intercept form. Alright, what's that slope? So a very important thing in graphs and functions and stuff is this idea of slope. Okay, and it's important because if we've got maybe this is time and this might be donuts eaten, okay, and so if someone is eating lots of donuts in a very short amount of time, they will have a graph that kind of looks like this, okay, because as time goes more donuts are being consumed, okay, but someone who is consuming the donuts very slowly would have a graph that goes like this, okay? And the slope is how much does the graph go up or down as it goes along, okay? And it's important to think about a rate of change, okay? So how quickly does the y value or the horizontal value change as the vertical value change as the horizontal value changes? It's a really important question. As we get onto calculus and things like that, we later on we'll get to start to be able to calculate rates of change and slopes of functions that aren't just a nice straight line. Okay? But we're starting here nice and simple. Alright, so the gradient of a function is the measure of its slope. Okay, so firstly we've got a couple of different ways to think about it. So we're always thinking, so importantly, you always need to consider the slope to be traveling from left to right. That's very, very important, okay? So, a measure of its slope. So you have ones that go like this, okay? So function's going this way. This is positive slope, okay? Because as it's going along, it's going up, okay? And you can have ones that go this way, okay, and so this would obviously be a negative slope, okay. You can also have ones that are like this, so your horizontal ones, let's pretend that's horizontal. This would be a slope of, so zero slope, no slope, okay. And when you've got your vertical ones, okay, these are an undefined slope. Okay, so it's very important. It's not an infinite slope, more so to the point it's just undefined. There is no slope to define there. Okay, and as I said, always consider the slope to be traveling from left to right. Alright, now if you know 2 points on the line, so x1, y1 is let's call that point A, and point B, x2, y2, you can calculate the gradient m from our y equals mx plus c. Gradient using this delta y over delta x, okay? Now delta y, so the delta thing means a change, okay? A change in, and to do that we get the final value minus the initial. Okay, so y2 is our final one, minus y1, our first one, okay? Or another way you can see it is the rise over the run. How much does the graph rise, positively or negatively, as it runs along, okay? And importantly, as I said before, vertical line has an undefined gradient. So let's have a look at how we might use this. So if we have A is equal to 7,3, B is equal to 10,5, we're going to have the slope being equal to the change in y over the change in x. So y2 minus y1, so that'll be 5 minus 3 over x2 minus x1, 10 minus 7. And we have 5 minus 3 is 2, 10 minus 7 is 3. So 2/3 is the slope for that graph, okay? Alright. And we can sketch a function using its gradient intercept form, so it's y equals mx plus c, because you can think about that as the y equals m is the gradient multiplied by x plus C is the y-intercept, which you may have already noticed. Okay, so let's have a look at using this function here, y equals 2x plus 1. So we know that the slope is 2, okay, and the y-intercept is 1, so negative 1, okay? So we know straight away that at y equals negative 1, here's where it has to at least cross, okay? But now, how do we deal with the slope of 2, okay? So, we have a slope of 2, means for every change in x equaling a change in x of 1, so every time it goes across by 1, it means it goes a change in y of 2, okay, which means it goes up by 2. Okay, so for every 1 we go across, it means we're going up by 2. So here is going to be our next point. Then we can go across by 1 and up by 2. There's our next point. Okay, and so that is simply how you calculate, you draw a graph from the intercept gradient form. Okay, so step 1 is you plot the y-intercept. Then step 2 is that you find another point using gradient. Okay, so quite easy to do. Right, let's have a look at some worked examples. So we're going to calculate the gradient in the following graphs. So we've been given a graph here and we've got 2 points listed for us. So 2, 5 and 1, 1. Now remember, we always do it going from left to right. Okay, so this is going to be our first point A, and this is going to be second point B. So gradient is delta, not delta x, delta y over delta x. Okay, and that's equal to y2 minus y1 over x2 minus x1, being 5 minus 1 over 2 minus 1, which is 4 over 1. So therefore we have a slope of 4 for that one there. Okay, gradient of 4. Okay, this one here, so we've got something a little bit different here. So we write down that our slope is equal to delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. And so remember, we're going from this way to this way, so this is our first point, this is our second. So first point, y2 is 5 minus y1 is 2. Our first x value is negative, our second x value, what am I doing? It's not erasing for me. Let's choose the eraser. Okay, let's fix that up. So y2 is this one, 2 minus y1 is 5 over 0 minus negative 4. So let's have a look. So 2 minus 5 is negative 3. 0 minus negative 4 is 4. Okay, so our slope for this one is negative 3 over 4, which makes sense because it's a negative slope. Okay, and for every 4 it goes along, 1, 2, 3, 4, it comes down 3. Okay, so it's really important for you to be able to look at your graph, so look at your gradient you've calculated, look at the function you're calculating it of, and say, does this kind of make sense? And we look at it, yeah, it kind of does, so we're okay with it. Alright, let's calculate the gradient of the line, which joins the points A, negative 2, 7, B, negative 2, 5. So I've labelled these A and B nicely, but you think about it, okay, negative 2 comes before positive 2, so that means that that's going to be x1, y1, x2, y2. So slope is equal to y2 minus y1 over x2 minus x1, which is equal to negative 5 minus 7 over 2 minus negative 2, which is equal to negative 12 over 4, which is equal to negative 3. Okay, so that would be the slope for that one. So quite easy, substitute them, work the fraction out. And finally, just sketching a graph of the function y equals negative 3x plus 5. So remember, the first things we need to do here is, let's go first, we're going to find the y-intercept. So that is, if it's already in this form, is the c. So that is this part here. So therefore, it's at y equals 5. And then secondly, we plot another point using the gradient. Okay, so we go down, we find y equals 5. So 1, 2, 3, 4, 5. And our gradient was negative 3. Okay, so that means it goes down 3 for each across by 1. Okay, so that means we go here, we go across 1 and we go 1, 2, 3 down. Okay, for every one we go across, we go down 3. Every one we go across, we go down 3. Okay, so see that's across 1, down 3, and we draw a line through that. Remember, obviously I want you guys to be using rules and stuff, but I'm just going to do a Dodgy Brothers line through here. And then we have our function, and it's a good idea to label this. This is y equals negative 3x plus 5. Okay, so sorry that video went for a little bit longer than usual, but it's really something very important for you to understand and be very familiar with the y equals mx plus c form and the kinds of things that you can do with it and what they mean. Okay, thank you so much for watching. Bye.